Human consciousness can enter a state so profound that the boundaries of identity completely dissolve. We often associate this with specific chemical interventions like psychedelics, yet the exact same psychological state occurs during catastrophic physiological failure. Historically, these experiences were relegated to the realm of metaphysics and religion. Modern neuroscience, however, treats them as rigorously measurable psychological phenomena. To quantify these states, researchers rely on a clinical measurement tool known as the Five-Dimensional Altered States of Consciousness Rating Scale, or 5D-ASC. This tool measures three primary metrics of the mystical construct: oceanic boundlessness, the experience of unity, and ego dissolution. Ego dissolution is the critical cornerstone of the state. It represents the total loss of the boundary separating the perceiving subject from the objective world. By isolating these metrics, we can treat the mystical state as a structured, replicable event. It offers a systematic way to observe the narrative self at its limit, providing a framework to investigate what happens to our identity when the systems that support it begin to fail. We can observe this construct in action through contemporary clinical data originating from trials utilizing classic psychedelics, specifically psilocybin and LSD. Subjects in these controlled trials consistently register remarkably high scores on the oceanic boundlessness and ego dissolution vectors of the 5D-ASC. Now, consider a seemingly unrelated dataset: the psychometric evaluations of patients who have survived cardiac arrest and reported near-death experiences, or NDEs. When we plot the NDE psychometrics directly against the psychedelic data, the shapes are nearly identical. Both groups report the exact same distortions in time, space, and a profound sense of ego death. A statistical overlap this precise strongly suggests a shared neurochemical pathway. Two radically different biological events, exogenous 5-HT2A receptor agonism and extreme hypoxic trauma, are producing nearly identical psychological outputs. This suggests that despite their different origins, both paths may lead to the same massive disruption in the brain's internal architecture. To understand that disruption, we have to look at the default mode network, or DMM. This is a group of interconnected brain regions responsible for self-referential processing and the maintenance of your narrative self. Classic psychedelics operate primarily as agonists, binding directly to 5-HT2A serotonin receptors across the cortex. When activated, these 5-HT2A receptors acutely disrupt the synchronous resting state firing that normally keeps the default mode network intact. This scatterplot compares data across psychoactive substances. While cocaine and alcohol cluster left, psychedelics drive high ego dissolution. We connect these reports directly to functional connectivity in these parahippocampal retrosplenial brain scans. The data demonstrates a strict inverse correlation. As functional connectivity in this circuit decreases, subjective reports of ego dissolution sharply increase. The phenomenological loss of self is the literal, observable decoupling of the brain's internal reality monitoring infrastructure. In network theory, losing coherent, synchronous communication within an established brain network is called disintegration. As the DMN disintegrates, disaggregation occurs, a sudden increase in crosstalk and connectivity between normally isolated networks. This combination of disintegration and disaggregation drastically increases global brain entropy, forcing the cortex into a state of neurocomputational anarchy. To explain how this entropy affects perception, neuroscientists propose the Rebus model, standing for Relaxed Beliefs Under Psychedelics. The brain normally relies on rigid, top-down predictive models, known as priors, to filter sensory information and maintain a stable reality. Psychedelic-induced entropy reduces the precision and authority of these top-down predictive models. Without top-down filters organizing the input, the cortex is flooded by bottom-up sensory data. The boundary separating the internal self from the external environment collapses. The unitive mystical experience is simply what consciousness feels like when the brain processes reality without the isolating algorithms of the default mode network. This brings us back to the dying brain. How does a near-death experience replicate this exact pattern of network desegregation without exogenous drugs? The endogenous catalyst is acute cellular hypoxia, the severe oxygen deprivation that occurs during asphyxiation or cardiac arrest. 5-HT2A receptor activation triggers transient vascular contraction, which leads to severe hypoxia-like responses and activates neuroplasticity mechanisms. Hypoxic stress induces necrotic liquidation. Brain cells begin blebbing, causing an immediate, massive efflux of neurotransmitters into the extracellular space. A popular theory explaining the resulting near-death state is the spirit molecule hypothesis, which posits that a massive release of endogenous DMT during death is solely responsible for the mystical experience. Chromatography data published by Dean and colleagues in 2019 seemingly validated this theory, proving that a measurable surge of DMT occurs in the mammalian brain following cardiac arrest. While DMT levels do surge roughly six-fold during this trauma, the mere presence of a molecule does not equate to primary causation. To understand what truly drives the near-death mystical state, we must look past the presence of DMT and examine the brutal mathematics of competitive receptor kinetics. The spirit molecule hypothesis faces a critical mathematical problem when we analyze the raw pharmacological environment of the dying cortex. DMT is not the only chemical released during this hypoxic brainstorm. It is competing directly against baseline serotonin. While DMT surges six-fold during asphyxiation, serotonin levels surge by over 20-fold. Furthermore, serotonin possesses a 10-fold higher binding affinity for the 5-HT2A receptor than DMT does. It binds faster and with significantly more force. The pharmacological conclusion is unavoidable. In a hypoxic environment, the 5-HT2A receptors are completely saturated by the serotonin dump, rendering the DMT mathematically irrelevant. This serotonin-driven receptor saturation directly causes the DMN decoupling and brain entropy observed in psychedelic trials. The brain's final defense mechanism against cellular death accidentally triggers the exact neurochemical sequence required to dissolve the ego. The mystical state of the near-death experience is a deeply conserved serotonin-driven collapse of the narrative self at the absolute threshold of biology.